is moving on the x-axis where Vx is shown on the picture as a function of time. The displacement in meters after 2 seconds is. So let's see. We know that the equation to the formula to find displacement is equals, it should be t, x of t equals x0, which is x initial position, times v0 plus v0 times t, where v0 is initial velocity times time, plus 1/2 times acceleration and times time squared. So to find, we kind of know everything except acceleration here. Why I'm saying that we already know everything? We know that the object starts from 0, 0, where time equals 0, displacement equals 0, right? So initial position is 0. V initial is also 0. When we multiply, so it's gonna cancel. Since it's 0, we don't need it. 0 multiplied by any number is also gonna be 0. So we can rewrite this formula, and it's gonna be x of t times, we left only with this 1/2 times a times t squared, but we don't know acceleration. So we need this formula, which is a equals acceleration equals delta v divided by delta t, where delta v is v final minus v initial, and delta t is t final minus t initial. So since we know that we started from 0, we can do, I didn't write it here, but we will have 8 minus 0 divided by 4 minus 0, right? Because we were moving with 8 meters per second at the end, but we started with 0 meters per second. And also for the time, we at the end ended up at 4 seconds, but we started at 0 seconds. So we are left with 8 over 4, which is equal to 2 meters per second squared. Plugging in here 2, since in the question they ask us about 2 seconds, where was the object after 2 seconds? So it's gonna be 1/2 times 2 meters per second squared, which we found here, acceleration, times 2 seconds that the object was moving, squared. So we got this cancel out. I mean, it's gonna be 1, since 2 times 1/2 is 1. So 1 times 2 squared is gonna be 4 meters, right? So object after 2 seconds will be at 4 meters, which is A.